Today, we will discuss about product rule for logarithms.
These are learning outcomes. These are defined properties of logarithm and use them to solve equations. Define and use the product rule for logarithms.
The equation at the top says log base b of x equals y. Note that base b is always positive and the logarithmic exponential functions undo each other. This means that logarithms have properties similar to exponents. Some important properties of logarithms are given in this section.
So, this is a zero and adding exponent rule for logarithm and exponential. So, this is an example. Use the fact that exponential and logarithms are inverse to prove the zero and identify exponent rule for the following. So, this is our sample of number 1. Log 1 to the base 5 equals 0, since 5 to the power of 0 equals 1. Number 2. Log 5 to the base 5 equals 1, since the 5 power of 1 equals 5.
Rewrite the logarithm as log 10 to the power of 2 to the base b and then apply the inverse property log b to the power of x to the base b equals x to get log 10 to the base 2 to get log 10 to the power of 2 to the base 10 equals 2. Number 2. Rewrite the logarithm as e log 7 to the base e and then apply the inverse property b log x to the base b equals x to get e log 7 to the base b equals 7.
The product rule for logarithms. Recall that we use the product rule of exponents to combine the product of like base raised to exponent by adding the exponents. X to the power of a and x to the power of b equals x to the power a and plus b. We have a similar property for logarithms called the product rule of logarithms, which say the logarithm of a product is equal to a sum of logarithms because logs are exponents and we multiply like bases. We can add the exponents. We will use the inverse property to derive the product rule below. The product rule for logarithms can be used to simplify a logarithm of a product by rewriting its sum of individual logarithms. This is how log mn to the base b equals log m to the base b plus log n to the base b for b is greater than 0. Log mn to the base b equals log m to the base b minus log n to the base b.
Given positive real numbers m, n, and b where b is greater than 0, we will show
log mn to the base b equals log m to the base b minus log n to the base b. M to the base b and n equals log n to the base b. And exponential form, these expressions are b to the power of m equals m and b to the power of n equals n. This is as follows that substitute for m and n. Apply the quotient rule for exponents. Apply the inverse property of logs. Substitute for m and n.
using the product rule for logarithms, rewrite the logarithm of a product as the sum of logarithm of its factors. Example, log w x y z to the base b equals log w to the base b plus log x to the base b plus log y to the base b plus log z to the base b. Analysis of the solution. It is tempting to use the distributive property when you see an expression like 30x open parenthesis 3x plus 4 close parenthesis, but in this case, it is better to leave the argument of this logarithm as a product since you can then use the product rule for logarithms to simplify the expression.
Summary. Logarithms have properties that can help you simplify and solve expressions in equations that contain logarithms. Exponential and logarithms are inverse of each other. Therefore, we can define the product rule for logarithms. We can use this to simplify or solve expressions with logarithms. Given the logarithm of product, use the product rule of logarithms to the right an equivalent a sum of logarithm as follows.
1. Factor the argument completely, expressing each whole number factor as a product of primes.
2. Write the equivalent expression by summing the logarithm of each factor.
So this is Ruby Jane Divino.
And I am Sakin. This is your teacher in mathematics in signing off. And thank you for watching. Bye!